All right. I will show you first slides and introduce the feature a little bit, but then we will get down to basics and look at some code. Let's see if I can get this to share my screen. Can you see my screen now?
Yes.
All right, we will get going. Let's start with the motivation for why we are doing null safety in Dart. This is actually not a new idea. If you look in our Dart SDK issue tracker and you look up issue number 22, you will see that this issue called support non-nullable types was filed on October 10th, 2011. So that's more than 9 years ago. So it's actually a long-running idea, but not one we've been able to act on first. As you may recall, we had to spend a lot of time in Dart 2 first to make sure we had a fully sound type system. And now with nullability, we're building on top of that, adding support for sound null safety. There's also been a lot of demand for this. We often use votes in our issue tracker as a way of gaining interest. And if you sort all the now closed issues by the number of votes, you will see that this is actually the highest rated or voted issue we've ever had in the SDK issue tracker. So as a product manager on the Dart team, I'm extremely happy to have this in beta now and hopefully in stable soon. What's it all about? It really boils down to getting away from hitting null errors at runtime to finding them at edit time when you write the code. If you have null errors at runtime, it means that very likely you can risk having your customers find your bugs. It's hard to have perfect test coverage, so some things will sneak through. You will publish your app in a store, and you will get poor reviews when your app is crashing. With null safety, it becomes part of the type system. So as you're writing the code, we can run analysis on it and show you the mistakes as you're making them, and you can fix them before you even finish your app and submit it, and you get happy customers. That really is the core motivation here. Let's talk about the principles. And these are some principles we laid down very, very early on in the design process as we were getting going on null safety. The first one is we want types to be non-nullable by default. So if you don't make a choice and you can create any variable, say of type integer, we want the default to be that that variable can only hold integers. It cannot hold nulls. And we think this is the right default because we looked at a bunch of APIs, we looked at some industry research, and it is by far the most common choice in APIs to have non-nullable variables. Of course, some things it is quite useful to use nulls, and if so, then you can of course still choose to do nullable types, but it requires you selecting that type, and it is not the default. By now, you may be worried that this sounds very breaking, and of course, we're not interested in breaking. So the second principle is very, very important, and that is this feature is incrementally adoptable. That means that you can choose what you want to null safe, what you want to migrate to null safety, and you can choose when you want to do that. When you migrate, you can migrate incrementally. You can run a mix of null safe and non-null safe code. It also means if you're a package author, you can migrate your package to null safety and publish it. And your customers who are not yet using null safety can still consume it without being broken. And finally, we provide a migration tool that I will demo later to help you with the migration. And then lastly, we wanted sort of to go a little bit beyond what some other languages do and try and differentiate. And as I mentioned, we spent a lot of time building a sound type system with Dart 2. Now we're adding soundness to null safety. Soundness means that if the type system says something is null, then we can trust it. It never is null. There are no exceptions. That's a very powerful thing, because if you know that something is never null, it means something like a compiler can actually trust it. And it means it no longer has to add null checks to the produced machine code when you AUT compile, for example. This ends up, in many cases, allowing us to create more compact, smaller code, and in some cases also faster code. There is one caveat here. You only get the soundness property for null safety if everything in your app, your project, which means your code and all the things you depend on, all use sound null safety. But once you get there, you will get soundness. Let's talk briefly about the timeline. We launched the technical preview back in the late summer. And back then it was an experiment. You had to pass an experimental flag, and it really was for us to get early feedback. But as you may have seen, a couple of weeks ago, we launched a beta version of null safety, and that beta version is currently available in the Dart and Flutter beta channels. Now that we're in beta, there is no longer a required experiment flag, which means you can go ahead and use the feature. And I will show you in a second how to do that. And it also means you can now publish any packages that you've migrated to null safety. And we'll talk a little bit about some of the guidance here. We're strongly recommending that you use pre-release versions and that you think hard before you use this in production. And then last, of course, when the feature is ready, we will look at the beta feedback. We will fix any issues we hear of, and then we will promote this to the stable channel. It's really hard to predict timelines because, as I mentioned, we're really doing this based on the feedback we're seeing and the quality feedback. But we're hoping this will be fairly soon, likely early next year. And then, of course, it'll be both in the Dart and Flutter stable channels. All right, so let's talk a little bit about the principles and what they mean in practice. And actually, instead of talking, let's take a look. And I'll hop out of slides here. Okay, still running, and we will go to my terminal. So we have a small program here, and we can take a look at this program. And as you can see, this is a pretty simple program. We declare a variable, and then we call round on it. And maybe you can see the mistake here already, but let's try and run it. Oops, here's one of those runtime crashes I talked about, right? Like we were calling round on the variable d, but we didn't actually initialize it to any value. And of course, there is no, so d is null, and there's no way of rounding a null, so we get a runtime crash. And as we talked about, this is not something you would have been told about as you were coding. Actually, we can try and run the analyzer here. And you'll see the analyzer will run on this code and say there are no issues because in the existing Dart language, this is a permitted program and you get an issue at runtime. Let's try and opt into null safety. To do that, we do something called language versioning. And language versioning is based on a familiar concept, which is the SDK constraint of your pubspec. So I'm going to edit the pubspec here. Maybe it gets a little bit bigger. And you can see here's the SDK constraints. We are currently saying that this code requires Dart 2.10 or later. Dart 2.10 does not have null safety. This is a new feature that we're currently working on, and we're working on it in the Dart 2.12 release. That means that the null safety feature is tied to the Dart 2.12 language version. So to enable support for this feature, I need to require that my app runs in Dart 2.12 or later. There's no stable release for Dart 12 yet. As I mentioned, we're in beta, so 2.12.0 doesn't exist, but we have some pre-releases. I could type out the full version number with all the details and beta. But they all happen to start with a number, a dash and a number. So if I add the dash and the number, it means this will work with any 2.12 pre-release.
Pardon the interruption, but could you increase the font size, please?
Okay. Is this better?
Yeah, I think, yeah. Thank you.
Okay. All right, so we changed the SDK constraint here to 212, and we'll go ahead and save this and go back, and we will run pubget. And now let's try and run the analyzer again. Now you will see at analysis, if I was in an IDE, I would have seen this as I type it. Here in the terminal, I run analysis, and you can see we immediately get told that we have a non-variable D. It has not been assigned, yet we're trying to invoke something on it. We can also try and run it. You see, we're not permitted to run it this time because the program has an analysis error in it, and you are not allowed to run programs that have analysis errors in them. So this, in my opinion, is a big step forward. We get told about the error as we're developing instead of at runtime. And as we saw, it is real simple to opt into null safety. All you need to do is to edit your pub spec and select the 212 language version or later. There is one exception to this rule that you opt into null safety, and I think it's important, and you may never hit this exception, but I would like for you to know about it in case you do. Here's a much simpler, here's a directory that has nothing in it but a single dart file. So notably, there is no pub spec here. And you can see that this program here is really simple. It declares two variables and does a print. And you know that this program should work just fine. But if I try and run this program, you will see I actually get a non-nullability error here saying I am printing J, but I did not initialize J. So this program is actually running with null safety. It is doing that because there is no pub spec. And when there is no pub spec, we cannot infer what your intentions were about language versions. And in that case, we default to the version of the SDK. And I'm running with Dart 212 here, so I get Dart 212 language semantics. So this will run with null safety. There are two ways to stop that from happening. I could add a pub spec here and make that, for example, have a lower constraint of Dart 210. But there's also a new feature we've added called language versions. So let's go ahead and edit this, and then we can just add a comment here at the top where we say add Dart equals 2.10. So we're just adding this very simple annotation here. This means that this file should be interpreted with the Dart 210 language version. I'm going to save this and then run it. And you will see it runs now without null safety. So the program is permitted to run. And of course, there's a null in here. So this is now more error prone. But it's an easy way of stepping back to the semantics of older SDKs, if that's what you want. But again, you have two choices. You can have a pub spec with the constraints that is, for example, 210, or you can use these annotations. All right, let's go back to the slides for a second. All right. So we've learned about how to enable null safety, how to not enable it if that is your choice. But remember, for the majority of all your existing codes that have pub specs, nothing will happen initially. You can install .212 and things will just continue to run. But let's say that you are now interested in migrating to null safety. Let's talk about how to do that. The first thing that's really critical is that order is important. We strongly recommend that you migrate in order. So here we have 3 packages, a package C that depends on a package B that depends on a package A. C could also be an application. It's the same principle. You have to start from the leaves of the dependency tree here. So here, package A is the one that should be migrated first. Then we can now migrate B because B only depends on A, and A has null safety. So B can be migrated. Then B and A have null safety, and given B is the only dependency of C, we can then lastly migrate C. When you do it in this order, you get soundness all along the chain, and you'll get a better experience. If you, by mistake, for example, happen to migrate out of order, so if you migrate B prior to A having been migrated, you get no soundness. That, of course, is an issue. But you can also get some issues that when A then finally actually does migrate and you upgrade to a newer version, semantics will change because the null safe type system is a little bit more restrictive. So code that worked before may stop working. If you migrate things in order, you get none of those issues. So it really is the best experience. There are 5 steps in total to migrate. The first one is to check for what I just mentioned. Am I ready to migrate? Are all my dependencies ready? Step 2 is to actually do the migration. Step 3 is to make sure that you pass all static analysis. As we saw already in my small demos, we had a program that did not pass static analysis, so it was not null safe. Then you should run your tests and make sure everything passes, and we will see an example of that. And then after all the 4 first steps are successfully completed, you can go ahead and publish. But again, enough talking. Let's take a look at these in practice. Okay, we are back here in my terminal, and we will look at this. So this here is a small example package. This is a package that calculates something called the Licks index, which is a readability index. So this library, you can pass it a piece of string, like a paragraph, and it will calculate how difficult this text is to read by a number of metrics. We can try and run the example here. So in the example, we pass a paragraph to this algorithm, and in this case, it calculated that the Licks readability index of this text was 40. All right, let's go back to our migration steps. Remember, the first step always is to check, are we ready to migrate? For that, we have a new command called dart out data, and then you pass mode equals null safety. Make this a little bit bigger. Here we go. So when you run this command, you will get this list with package names on the left, and then we get 4 columns: current, upgradable, resolvable, and latest. Current is the version that is currently in my pubspec YAML and log file. So that's what I'm currently using. As you can see, that's marked in red. That means that my current versions of these 2 dependencies, collection and test, do not support null safety. All the way on the right, we see the latest versions. Those are the latest versions on pub.dev, and you can see they're green, so they both support null safety. Resolvable is looking at the, when you look at all my dependencies together, because remember, one of your dependencies could depend on another dependency. So when you look at the combined resolution of all your dependencies, what are the most recent versions you can get to? In this case, that imposes no extra limitations. So the set of resolvable versions are the same as latest. And then upgradable is the set of versions I will get if I run pub upgrade. And we can see in this case, it is not sufficient to run pub upgrade because my current constraints do not support the resolvable versions. So to fix that, we need to edit our pubspec to be more permissive. And I've personally found the easiest thing to do is just to copy the output here, and then we can use that when we edit. So we go into our pubspec. I'm just going to temporarily paste this at the bottom. Then for collection, you can see we're currently limited to 113, and we need 115 in the null safety pre-release. So I'm going to copy this here and then paste that in up here, and I'll do the same here for test. And then we don't want to leave this at the bottom. So we've simply raised the constraints here to allow some more recent versions of collection and test. And I'll save this and go back. And we will then run the outdated null safety tool again to see how we're doing with these new constraints. And now you can see with the constraints we have in our pubspec YAML, we now actually do allow these versions. That's not so surprising because I just changed them to be the same ones. And that means with this, we can run dart upgrade, and we will run a resolution and write that into the log file. that worked. So just to make sure that everything happened correctly, we will run this one last time, and we should see that, yep, all versions support null safety. So to recap, we used the new tool to see if null safety versions of our dependencies were available. We then used the version information in the tool to apply those to our pub spec, and we then ran upgrade to make sure that we're using these versions. That means we are now green to begin our migration. In some cases, you may find that this is not possible. When you look at the resolvable column, one or more of your dependencies are red. There is no version that supports null safety. This will happen probably more predominantly here early on in the phase as you're waiting to get everything migrated. If it happens, I would recommend that you go and find the package that is missing null safety on pub. You look up the source code repo and you see if it's already tracking an issue to add null safety support. If not, perhaps you can open a request on the author and ask them to kindly support null safety. We in the Dart team will also be doing a bunch of work on some of the more popular packages to really try and push things along. But in this case, for our demo, we're good to go. Let's move on to step 2. Step 2 is to do the actual migration. So for this, we are going to run actually, first, let's just open up the code in an editor so we have that available. It's here, and then we are going to run the migration tool. And that is a new command called .migrate. This starts by running analysis on the code. Right now, it's checking, for example, that I did the previous step correctly. Had I not upgraded my dependencies, I would have been told by this tool and would have refused to do the migration. But in this case, everything looks good. The UI for this tool is a little too, it has too much information to present in a CLI. So we've built a web UI for this. So I can go ahead and copy this address here and then put that into my browser. I'll try and make this a little bit bigger. Here. So it has sort of a 3-pane layout. On the left-hand side, we are seeing the files that are in this project. And you can see there's a little counter that says 8 next to licks.dart. That means that there are 8 points of interest in that file that we should look at. Then in the middle, we will see the code. So I'm going to click this thing here with points of interest. And then we'll see some more information over here. I'm going to start with the bottom here. At the bottom here is a function that's called describe. And in my existing code, it returned a string. So for all types like this, the choice, of course, is should that continue to return a string which has now become non-nullable, which it wasn't before, or should it still allow nulls, in which case we will have to add a question mark here to select the nullable string type. I can click this little square here and we will see some more information over here. And we'll see it says it's found no reason to make this nullable. It means it's looked at the code. And actually what it does is it looks at the body of the code here and it sees what's happening with the return values. And as you can see, we're running through a fairly elaborate if-else statement here. But in all the branches of this if-else statement here, we are returning a string. So there is no way this function here could return a null, and thus there is no need to make this nullable. So we actually do a lot of analysis and inference of the code that allows us to here say that there is no reason to make this string nullable. It's the exact same thing up here for the calculate method. We can see both the local result variable here and the return type. There's no reason to make either of them nullable. The result here, because that is being assigned to in all branches. And you can see it's a fairly elaborate analysis because we assign to it only in the else branch, but in the other branch, we throw an exception. So in all the paths that complete successfully, we assign a value to result, and thus it can be non-nullable. And then lastly, of course, we return a result, and the result is non-nullable, which means that the return type is also non-nullable. So this all looks good. There's no reason for me to tell the tool to do anything different. Let's go towards the top. Towards the top here, you will see a pretty common pattern where we have a class with a constructor and then 3 named parameters: words, long words, and periods. And these named parameters then have local instance variables here. The tool is suggesting that each of these 3 variables should be nullable, and it is suggesting that because we are initializing them from a named parameter, and as you may recall, named parameters are not required. I could call licks without passing either of these 3, and because they're not initialized, if I don't pass them, it means that they will end up being null if I call licks without passing them. And thus it is suggesting that. There is a way of avoiding that. I could, for example, and you see this very commonly in Flutter APIs, we could require that these named parameters have to be passed. So I can go up here and say words here. I would like to tell the tool now that I don't want this to be nullable. I want this to be non-null. And I do that by adding a hint here, which is the exclamation mark hint. And now if I rerun the tool by pressing the rerun with changes button, you will see it's going to add required in front of words because I said I don't want nulls, and the only way the tool can guarantee that is by adding required. You may wonder how these hints work, and they're really just comments, as you can see. That also means if we go to our code editor here, you will see if we go into the library, let me make this a little bit bigger, you will see that that same comment is in the code here. And that also means I can actually write comments like this in my code before running migration. So I'm going to add this same comment here to long words and save it, and then go back to the UI here and click rerun from sources. And you will see that the hint is now going to appear here. So you can you can add the hints if you prefer in your code editor of choice. So you can add them here in the UI. You can do that at one point in time, or you can do it as part of running Migrate, but you could also do it in advance of running the actual migration. And we've actually done that in some of our own code as we've been writing the code. There's one last choice for name parameters. So you can make them nullable if they are not passed. You can make it required to pass them, in which case you will get a default value from the caller. But the last choice is you could also just give them a default value. If you want to do that, you'll have to do that in your IDE. So I could go here and say periods here actually should have a default value of 0. And now if I go back and rerun the tool, you will see that periods here is also no longer being marked as nullable because it now has an initial non-null value, which is 0. All right, once we're happy with this, we can go ahead and click Apply Migration. And what Apply Migration will do is now we will actually write into your code all the type changes that we've just annotated. So now the any hints with question marks in it will become actual question marks and not in comments. So if we go back here, you will see that the comments are all gone, and we've applied the null safety versions of all the types. All right, so step 2 is to perform the actual migration. Step 3 is to look at static analysis. We could do that in our terminal again by typing _ analyze, but often you will be in an IDE and you can see there actually is a static error waiting for us here at the bottom of my pane here, and it looks like it's in one of my tests. So let's take a look at this one. And what this is I had a test case before to make sure that this code would fail correctly if I passed a null, because there was no way I could prevent callers from passing null. But now we can prevent callers from passing null because the from string method that we have here, if I go to declaration, you can see it takes a string, not a nullable string, but a non-nullable string. It means we can guarantee that this will never be called with null. That also means that I don't need this test case anymore. It's not a valid test case because it's testing something that can't happen. So the correct fix here is just to go ahead and delete this test case, and that of course will make the analysis error go away. Okay, so we are done with the migration. We have checked that static analysis is passing, and just to check here, we can go back here and also just check here to be entirely sure. And then move on to step 4, which is to make sure that tests pass. So we will go ahead and run tests. There's only a couple of tests here, so it shouldn't take long. Which of course it is, because I'm doing a demo. I'm not sure what's happening here. Oh, here we go, finally. And our test should pass. Yes, perfect. All right, so we've passed step 4 to make sure tests are passing. It means we can move on to the final step, which is to prepare for publishing. Remember I talked about the guidance here. We recommend that you publish as a pre-release version. And let's just quickly look at our guidance for this. Here. So there are 2 parts to this guidance. The first part is that we can recommend that you publish as a major new version. We do this as a practical recommendation. We found ourselves that when you migrate to null safety, you will often want to do some tweaks to your APIs because there are some APIs that are more natural once you have null safety. And to make sure that you don't end up doing some API refactoring and forgetting about it, we find it more safe just to use a new major version of your package when you migrate to null safety. We also strongly recommend that you publish as a pre-release version on pub to make sure that prior to the feature being stable, we can keep things separate. So let's do that, apply those 2 principles to our little library here. So we will do a new major version. That means going from 1.2 to 2.0. And we will make this a pre-release version by adding a suffix here, which we recommend is null safety. And then we recommend a numbering scheme here where for the first null safety version, you use .0, then .1, .2, and so forth. But we will start with .0. Let me go ahead and save that. And now I could go ahead and publish this package, and it will be available as a pre-release on pub.dev. And you will see this for many of our packages. If you go to pub.dev and let's take a look, for example, at collection. You will see collection here is in the 114.13 stable version. That version does not have null safety. But if we go on the 1.15.0 null safety.5 version, you'll see there's a little tag here that says null safety. That means that this version does have null safety. And you can see the same thing when you go to API docs. There'll also be various decorations there to tell you that this code is using null safety. All right, we've made it through all 5 steps to migrating to null safety, and that concludes the end of my demo. There's a bunch of resources if you want to learn more. We've published some fairly comprehensive blog posts along the way to null safety, and I would recommend that you check those out. They include many more details about why we're doing null safety and what we think the benefits are. The starting point for documentation is dart.dev/null-safety, where you will find the migration guide that has the 5 steps I just talked about for migration, and a lot of details about the ergonomics of how to write code that uses null safety. Many more details about inference that I mentioned and a few other things. If you want just to try and write some null safety code quickly, there is a version of Dartpad that has null safety enabled. By adding null safety dot in front of Dartpad, you will get to that version. We have samples of null safety in the Dart samples and Flutter samples GitHub repos. And if you search for null safety introduction on YouTube, you will find a video that introduces the feature in 5 minutes. With that, that concludes my presentation. I'm curious to hear if there are any questions.
Okay, thank you very much. Actually, our audience is enjoying, as far as I can see from the comments, the not nullable feature. We're just in love with it. Hey, and I have a question for you. Why wasn't it the default when the Dart was firstly developed?
Dart started a long time ago, more than a decade ago, and we started for something else. We were quite focused on the web initially, and the majority of our customers would come over from JavaScript that had a very, very different typing system. So we designed it for a different time. We designed it for a different set of customers. As you may also recall, we had a very different type system back then, where types, for example, were merely annotations, and you could do things like state something was an integer, yet assign a string to it. So it would have been very hard to do null safety in the initial Dart language, because it was designed with a very different type system in mind.
Okay, and you decided to develop the feature after the issue was posted? Or were there any talks before that?
We've actually talked about this a number of times since 2011. I think roughly every year on the project, someone's brought it up. But we finally realized, after spending a long time on strengthening the type system and seeing all the benefits people got from the Dart2 type system, that it was about time that we took the next step. But it was not an easy task. I mean, it was a big feature to develop, and it will be a big feature to adopt across the whole ecosystem. I don't want to take that too lightly, but we strongly believe that it's worth the cost. And I can tell you already internally now, we have many projects that have adopted it, and we've found a number of critical errors that we could not find before in the process of migrating. So I personally think it has been worth it.
Yeah. Another question from the audience. What will happen after 2.12 release? How much time will it take, in your opinion, to be able to get away with a new project which is null safe and to have all dependencies support null safety?
That's a great question. I ask myself that question nearly every day. But as you can also recall, it's a very hard question to answer, because it involves asserting statements about an ecosystem that none of us control, right? We will do our best. We are pushing really hard for all the packages owned by the Dart team, the Flutter team, the Firebase team, and so on. And we will do our best to get the vast majority of those migrated before stable. Actually, the majority of them are already in pre-releases on pub.dev as of today. We are already working with some of the package owners that we can see are the most foundational. We've run some analysis on the pub specs and looked at what are some of the leaves that are most common in the ecosystem. And we've personally reached out to those owners to get them to migrate. So we've done a lot of work to try and make sure that a large percentage of developers can use this when we get to stable. But I'm sorry, I can't answer the time question. I hope it will be a short time, but we'll see.
Yeah, we'll see. Okay, another question is, will there be in Dart something similar to .isPresent check in Java? I mean, just isPresent check. To check if value is present, or for example, in Kotlin, they have let operator that does the same thing.
Yeah, I think I don't recall the most recent details. I know we've talked about this a couple of times. But I don't think we ended up doing that for the initial version. We will continue to refine null safety even after stable. There are a lot of things that you can add on incrementally to the feature without changing the core semantics. And we prioritize getting the core feature out as quickly as possible. And with that, there are a number of refinements that we've postponed to later. But we will continue to refine it even after launch.
Okay, so that's in plans to add an operator.
Yeah, I don't recall the concrete status of this particular request, but in general, we will continue to look at refinements and any suggestions we may get from the community.
Okay. I'm not sure if you're allowed to answer that, but what is the next milestone for Dart?
What is the next milestone? It is to get null safety to stable. That may sound like a cop-out answer, but this is a monumental undertaking. We've worked on this for nearly 2 years now. Practically the whole Dart team has been involved. as you can imagine, it's not just the language team. It impacts any team we have, whether they do analysis or compilation, whether they do tooling like pub.dev, it has impacted, Dart generation, anything we have has been impacted. So the whole team has been engaging on this for years now. So really the next big thing is to launch this. I'm sure the next session will be what is the next big thing after that again, and we'll see. We have a number of things we're investigating, but it's very, very early because we've spent so much of our capacity on this.